Hi, happy Friday. We've made it through a week of remote learning. Hope that everyone's healthy, doing well. Um, and yeah, that you're not driving your parents crazy and your parents and siblings are not driving you guys crazy too. So now we're going to talk about multiple bonding. So as you looked at the notes, so we have single bonds we already know about. So that is just a single line connecting two atoms that's made up of two electrons. But when we don't have enough, we can also have double and triple bonds. So a double bond has two lines, each is worth two, so that's a total of four. And a triple bond has three, which equals six. Now these still tie into when we're talking about you can have eight total electrons or something. There are no quadruple bonds. The bonds are not strong enough to handle that. When we come back to school, we will do a lab where we do a modeling kit with this, and you will be able to see that that does not physically work. But for now, this will help us. Okay? And so basically the principle goes along the lines of if you don't have enough, you have to share. So if you imagine you go out for food with people, and you always feed your little siblings first if your mom gives you money to go out because we don't want mom to kill you. But if you spend all the money and there's really not enough for you, if you ate some of your siblings' food but you made sure they were fed first, mom's not going to get upset with you. So that's kind of the principle that I used to think of here. Okay? So let's start with CO2, carbon dioxide. So C brings 4. Oxygens each bring 6. So 6 times 2 is 12 plus 4 equals 16. C goes in the middle. Okay, so out of our 16, we've used 2 and 4. 6, 8, 10, 12, 14, 16. Okay, we're out. Now, carbon's not happy. Oxygen, they each have 8, but carbon's not. So you pick a side, pick your least favorite sibling. You take away 2, and instead of them being a lone pair, you make them into a double bond. Okay? So now this oxygen has 2, 4, 6, 8. This still has 2, 4, 6, 8, and carbon has 2, 4, 6. Still not happy. We go to the other oxygen, take 2, and make another double bond. So now we check. We have 2, 4, 6, 8, 10, 12, 14, 16 like we're supposed to. Oxygen has 2, 4, 6, 8. Carbon has 2, 4, 6, 8. And the other oxygen is 2, 4, 6, 8. Now, someone's probably thinking, couldn't I have taken all of them from one and had, for example, a triple bond here and a single bond here? Yes, you could, but if you can balance it out, you always try to. So although this is kind of correct, it's like when your mom asks where you are and you say, New Jersey, it's not the best answer for what you have. So if you can, you always balance them out. Okay, N2. So N is 5. 5 times 2 equals 10. There is no central atom because I only have 2 of them, okay? So out of 10, I've used 2. You pick either end to start with. So I have 2, 4, 6, 8, 10. Obviously, there's already a problem. So the N on this side has 2, 4, 6, 8. This one only has 2, 4. So we take 2, we share, and then we check again. So I have 2, 4, 6, 8. Okay, that's good. 2, 4, 6. This N's still not good. We share these two. These two move in to be a triple bond. So we still have our 2, 4, 6, 8, 10, but each N has 2, 4, 6, 8, and this N has 2, 4, 6, 8. Okay, carbon monoxide. C and O. Okay, 4 plus 6 equals 10. Okay, so I have 2. I'm just going to spread them out. I'll start with the O because it's more electronegative. Doesn't really matter when you're doing this though. So I have 2, 4, 6, 8, 10. And really, I don't care which side you put the dots on. So up here, for example, if these have been on top, that's perfectly okay. It's not happy. I'm going to take 2 away. Make a double bond, check again. O has 2, 4, 6, 8. It's happy, but carbon only has 2, 4, 6. So I'm going to take another 2. So I'm going to have a triple bond, again, just like nitrogen. And I'm going to have 2, 4, 6, 8, 2, 4, 6, 8, and there's 10 total. Okay, now we're going to look at O3. O3 is actually ozone, which I'm sure you've heard of, but now you know what it looks like. So 6 times 3 equals 18. You just make them in a straight line. Okay? There's no fancy way. You don't connect them in a triangle. That's not a sustainable pattern. Okay, we have 18. We use 2, 4. We work on the outside first. 6, 8, 10, 12, 14, 16. We have 2 more to give. We give them to the middle oxygen, and we check. And we say, hey, the middle oxygen, it's not happy. It's only got 2, 4, 6. You pick one side, does not matter which. Okay, erase 2. Make a double bond. You could have done either side. It really does not make a difference. Okay? Now, you may have noticed I skipped SO2 1-. We're going to come back and talk about that tomorrow when we talk about resonance. What resonance means is if you notice it's not equal here, we're going to look at what it means to be equal. So you're going to try the ones from your packet that are listed in the Google Doc, check your answers, and then you can try the other ones, take a picture, upload. If you have questions, please reach out, and have a wonderful weekend if I don't talk to you or hear from you.